So what we're doing today is we're going over the review sheet. Now, I did have these formulas listed up yesterday. Yes. Now, I did have all these listed up yesterday, except I realized I had someone ask a question about one of them, the ones for 7 through 10. I forgot to put those up there. Now, the one for vertex, if it's in vertex form, isn't a big deal because we already have a few equations and understanding of how that works. But if it's in standard form, ax squared plus bx plus c, it might be helpful to have those written down. So I'll leave those up and you can work on those. Make sure to have those down because I will not have those written up during the test. So it'd be good to have those written down. I can post those up on Google Classroom if y'all want. Okay. Let's go on and start the review sheet so y'all can have those, work on those here in a little bit. Now, problems 1 through 6 describe the transformation. Is there one of these in particular that y'all want to look at on 1 through 6? 2 and 3? So number 2, we're describing the transformation, so we'll really work from the left to the right. And now the first thing we have is a negative outside the parentheses. Well, a negative outside the parentheses tells me that I'm going to have a reflection across what? The x-axis. Because if we have a multiplication of a negative, either inside the parentheses or outside, it's going to be a reflection. Outside is across the x, inside is across the y. And when we go inside the parentheses, we just have x, so nothing is affecting the x, plus 1. Well, that would be 1 to what direction? Left. Since it's positive inside the parentheses, it's the opposite of what we think. So since it shows up as x plus 1, it would be 1 unit to the left. And since we have nothing else affecting it, we don't have anything added on the outside, or multiplication of a number besides negative 1, outside the parentheses, or a number being multiplied by x inside the parentheses, we have covered everything. And that's it. So really on the transformations, really just start from the left and go to the right and just address them as we hit them. Because when we're addressing what the transformations are, order doesn't matter. Because we're just saying this is what happened. And it's already been applied. The only one we'd have to be careful of is if there is a reflection and a translation. But I believe on the test there won't be anything too tricky like that. Now if we look at number 3, we do have 2 negatives. A negative outside and a negative inside. So that means we do have a reflection across what? 4 would be technically a little bit tricky because it would be considered negative x plus 1 squared plus 2, because it would be a reflection across y-axis up 2 and left 1. I think because of the reflection across the y-axis, it really throws it off. And if y'all remind me, because of the reflection across the y. Yep. It should be left 1. I'll fix that later. I put a note to myself and remind me, we'll pull up the graph of this and see how it compares to x squared. Actually, why not? Let's just do it now. cosmos. So our normal function would be x squared. That's our normal function. Now what we have is parentheses, negative x minus 1, close parentheses, squared plus 2, yes? So when we look at this graph here, our vertex for the original one is at the point 0, 0. Our new vertex is at the point negative 1, 2. So it really does change that movement left or right. But it's not going to be too nitpicky on those because I'm not, most likely I'll go and look at it here in a second, but I have a feeling those kind of problems aren't going to be on there. Yeah, because how we have it, it would be left 2. Now we could technically probably write it as right 1, reflection across the y-axis, and then up 2. But we would need the left and right movement to happen before the reflection to be able to say right. Any other questions on 1 through 6? Yes.
How do you know the difference between a vertical stretch and a string?
A vertical stretch, the value in front.
Say number 1 with a negative 2.
It would still be a vertical shrink. Just because it's negative does not make it change from stretch or shrink. The negative is a reflection. The negative is the reflection. Because if it's between 0 and 1, it's a shrink. If it's greater than 1, it's a stretch. The negative just refers to it being a reflection. Questions on this here? Questions on 7 through 10? Which one? Number 9. Well, we can do 7 because vertex for 7 would be what? 1, 5. The axis of symmetry would be x equals. Now again, for axis of symmetry in directrix, where it has x equals or y equals, you have to have it. You have to have the x equals or y equals. I gave you guys some leniency on the homework if you didn't include it, but on the test I will be marking it wrong depending on what you put, because again, the directrix is h minus p or k minus p. Because the directrix for one equation is x equals h minus p. The other is y equals k minus p. If you don't put the x equals or y equals, I will count off. Okay? Now, number 9, we have f of x equals 6x squared minus 4x plus 5. Well, that is in standard form. Well, the vertex for this here is negative b over 2a, comma, f of negative b over 2a. So looking at problem number 6, negative b over 2a. Well, what's the value of b? And a would be, because again, this is matching up with the equation what? Ax squared plus bx plus c. Ax squared plus bx plus c is the equation that this lines up with. Now at this point here, all we need to do is simplify this. So this would be negative 4 over, well, not negative 4, it's going to be positive 4 because the negative and negative make a 4/12 is the same as 1 over 3. So that's the x value of the vertex. Well, it also tells me that the axis of symmetry is x is equal to 1/3. Because the h value of the vertex will be the same value that we have for the axis of symmetry. Now, all that leaves us with is finding the y value of the vertex. Well, all we've got to do is plug in 1/3 in for x and find the value of y. Because all we've got to do is plug it into the function. Now at this point here, we can type this entire thing into the calculator and it'll do it for us. Or if we did it by hand, 1/3 squared would be 1/9 minus 4/3 plus 5. Well, it works out that 6 times 1/9 is 2/3. So 2/3 minus 4/3 plus 15/3, because if we were going to add or subtract fractions, we have to have the same denominator. So we have 2 minus 4 plus 15. Well, 2 minus 4 is -2. Plus 15 would be 13/3. But again, if you plugged it into a calculator, it would do it for you. Any questions on this here? Now on the ACT for tomorrow or Tuesday, if you have the graphing calculator and the TI-30XS, the yellow calculator, for a problem like this here, 6 times 1/3 squared minus 4 times 1/3 plus 5, I just use the yellow calculator because it's a little bit easier and faster to type fractions in on the yellow calculator than it is for the graphing calculator. But any other questions on 9 or 10? Or 7 or 8? We good with 7 through 10? Well, what's on the front, 1 through 6, is describe the transformation. So we're describing how is it moving from its parent function. So our stretch, shrink, translations up, down, left, right, stretch, shrink, and reflection. Here we're finding the vertex and axis of symmetry. Any questions on 11 through 16? Okay. 13? Yeah, we'll do 13 first, and then we can do 11. Now, we have 4x squared minus 8y equals 0. Well, we do see that x is being squared, yes? So we need to get the y by itself. So what can we do first? I'd add 8y to both sides because negative 8y plus 8y is 0. So really I'm saying that 8y is equal to 4x squared. And I flipped it because I like having that y, the one that's going to be by itself on the left-hand side, is y by itself. What do we have with y? So I need to divide both sides by 8. Now, 8y divided by 8 would just be 4 divided by 8 is same as 1/2 x squared. Now, I left the square off to the side because, again, for these here, since I'm trying to find the vertex, well, not vertex, but focus, directrix, and axis of symmetry, I know I'm going to be matching it with the 1/4p equations. Either x equals 1/4p times y minus k squared plus h, or our y equals 1/4p parentheses x plus h squared, x minus h squared plus k. I'm going to have one of those two. So I need it in this form. Now, vertex, even though it didn't ask for it, is going to be the point 0, 0. Because do I have any value being subtracted from x in parentheses? Or anything added onto it? Well, no, the vertex is going to be 0, 0. Now the focus. Well, since it's y equals, I look over at my chart, or my given equations, and it tells me the focus is h comma k plus p. H comma k plus p. Well, I do know h and k are both 0. Do we know what the value of p is yet? Is p 1/2, or is this matching up with our 1 over 4p? It's matching up with the 1 over 4p. So we could probably see and get to it that it is actually 1/2, because 1/2 is the correct answer, but it's not because the 1/2 is in front of x squared. That just happened to be coincidence. Now our directrix is going to be y equals, well, this would be our k minus p, and our axis of symmetry would be x is equal to h, which is 0. So really what this leaves us with is finding the value of p. So we set 1/2 equal to what? 1 over 4p, because 1/2 is in that same place as 1 over 4p. Well, the first thing we can do is multiply both sides by 4p. Well, 4p and 4p simplify, which gives us 1 is equal to, well, what is 4 times 1/2? So we have 2p. And last but not least, we would by 2, which tells me p is equal to 1/2. So coincidentally, p is 1/2, because 4 times 1/2 is positive, or just a 2. So we have 1 over 2 when we plug it back in. Any other questions on how we found p? So up here, the focus, k plus p. Well, k is what? Plus 1/2 is 1/2. K minus p, 0 minus 1/2 is, and that's it. That's all we have to do for this here. Because I think after we did that one, we noticed that 11 and 12 are already set up in the correct form, so we just find p. Any other questions on 13 before we move on to 15? 14? So we have -3. -3x minus 4y squared. Well, the x is the one that doesn't have the power, and both of our equations are really the variable that is not squared. We need to get it by itself. So what can we do first? Add 3x to both sides? If we add 3x to both sides, it's really saying that 3x is equal to -4y squared. And then what can we do? Which tells me that I have the equation x is equal to -4/3 y squared. Well, on this here, the vertex is still 0, 0. Because if I'm having to manipulate the equation for what we are covering, it's going to be 0, 0. We don't have the let me rephrase it. You don't have the resources at this point to actually get the equations in this form if the vertex was not 0, 0. We have not covered completing the square yet, and that's required for getting it back into this form. That also tells me what? Well, I have the -4/3, yes? So I can set it equal to what? 1 over 4p. Because those are in the same place, that's where I can find the value of p. Now the first thing we can do is multiply both sides by 4p, because the 4p and 4p would simplify, giving me 1. Unfortunately, 4p times -4/3, yeah, -16/3, because nothing will simplify over here, because 4 and 3 don't have any common factors, so it won't simplify down like it did in the last one. Yeah, because it's always multiplied by the top, because really we're multiplying both sides by 4p over 1. We always multiply a number to the numerator. Now, at this point here, we can divide both sides by negative 16/3, or we can multiply both sides by what? They both be negative, what? 3/16, because I can divide by the number or multiply by its reciprocal. I can flip it. Because the 3 and 3, top and bottom, would simplify to 1. 16 on top and bottom would simplify to 1, which would just leave me with p equals negative 3/16. Yes, sir?
Could you also multiply both sides by 3 since
Yes.
the side is negative about 3?
We could have, yeah, at the very top, we could have just also multiplied both sides by 3. That would have worked as well. Yeah, so really, if we did that, we'd have been multiplying both sides by 4p and 3, or 12p, because 4 times 3 would be 12. Because 12p times negative 4/3, well, the 3 and 12 and the 3 on bottom would cancel, really just telling me that 4p is equal to, well, it would be 16p is equal to negative 3. Divide by 16, we get to the same spot. Yeah, so you can do that. Now the focus for this here, because we do have x equals, is h plus p comma k. H plus p comma k. Well, I know k is, well, h plus p would be, I'm going to erase this here so we can still see this, because h plus p would be 0 plus negative 3/16, which is negative 3/16. Because we don't have a value for h, or well, the value of h is 0, so it's not changing the value of p. Now the directrix would be x is equal to h minus p, which would be 0 minus negative 3/16, which is, and last but not least, the axis of symmetry would be y equals. Is it? Huh. Yes. I'd have x instead of y.
No, you have
Okay. Yep, I'll fix that. Yep, I just have them flipped. I'll fix that on the review sheet. Any questions on this here? We feel good with this here? (15 and 16). Actually, these will be the exact same, because 15 and 16 are the same as this here, except we are starting here instead of having the variable by itself. Because here we already have x equals y equals, so we would set it up, find p, and then plug in. So on those last ones, we were really finding h, k, and p and plugging them into the vertex, well, not vertex, but focus, directrix, and axis of symmetry. 15 through 19, well, again, we're finding h, k, and p, but instead of plugging them into the focus, directrix, and axis of symmetry, we're plugging it into the equation. We're going the other direction. Well, the directrix to x equals, well, that already tells me that I'm dealing with x is equal to 1 over 4 parentheses y minus k squared plus h. Now, I will tell you this here because the focus and directrix have the same exact value. That tells me h has to be what? Because what's the only number that I can add or subtract the same thing from it and end up with the same number? Is if it's 0, because 0 plus 1/4 and 0 minus 1/4 would still give me 1/4, different sign, but we'd still end up with the same thing. Because 1 plus 1/4 and 1 minus 1/4, that's going to give me two different values. So it's telling me h and k are both 0. 1/4 parentheses, because we don't know what p is, but we have y minus 0 squared plus 0. But I do know that the directrix is going to be h minus p. The focus is h plus p, yes? But do we know the value of h? Well, yes, we said it was. Would it be easier to solve for the focus or directrix? Because we're saying that h plus p is equal to 1/4. Well, h is 0, so p is 1/4. Plug it in. What is 4 times 1/4? So that whole fraction, this entire thing reduces to, well, y minus 0 is just y squared, yes? That's it. So really on 15 through 19, we're finding the values of h, k, and p and plugging them into the equation. Is there another one of those that you all want to look at?
Yeah, let's do it.
18? So looking at this here, well, they gave me the vertex as 0, 0, so h is 0, k is 0. Well, that doesn't tell me much. But I do get the focus is 0, comma, -4/5. So from the vertex to the focus, the value of y did change from 0 to -4/5. Y equals, because that's the one where the focus and vertex, we do have a change in the value. So we have y equals 1/4 times p times x minus h squared plus k, yes? Now we can go on and fill it in, because h and k are both 0. So x minus 0 squared plus 0. Now we just need to find the value of p. Now from the focus, I know that this would be k plus p. So k plus p is -4/5. What's the value of k? 0. So it's pretty much gone. So p is negative. Well, 4 times -4/5. Will that make the fraction go away? No, so we might as well just go on and plug it into the calculator and let it deal with the fraction inside of a fraction. Because if we did multiply 4 times -4/5, we would get -16/5. And if we plugged it into the calculator, I believe it should tell us that it's -5/16. Do you all agree with that there?
All right.
X minus 0 squared would just be the same as x squared, and we can drop the plus 0. So that's our equation. Now, the only reason we can really drop those parentheses is because x minus 0 is just x. If we had x minus 1, we would leave the parentheses there. Or x plus 1, x minus any number, y plus any number. We just leave them there. Any other questions on this here? Questions on 19? Well, 19 would be almost the same as 18, except instead of having our, so this here would be our x or y equals, well, the directrix is k minus p. So like what we did on the last one, we set up k plus p equaled the y value of the focus. Here we would set it up as k minus p equals what? 7. If I want to find the value of p, k minus p equals 7. What's the value of k? 0, so negative p equals 7, or p is equal to negative 7. What's h and k? 0 and 0. So we'd have y equals 1 over 4 times negative 7 times x minus 0 squared plus 0. Because the 4 times negative 7 would be negative 28, or negative 1/28 times x squared. And that would be it. That's all we'd have to do for this here. So any other questions on these problems here? We ready for the next set? Questions on 20 through 23. So on this here, we're trying to find the values of what? H, K, and P. Okay, so we do need to find the values of H, K, and P to be able to find the vertex, focus, directrix, and axis of symmetry. Because once we have those, then we can solve. Now, what's the value of H? K is? Now this here worked out that they were both negative 1. Now we know that the value of H is negative 1 because it's minus 1 on the outside. K is negative 1 because we have plus 1 on the inside. Now the only thing we're missing is P. But where would the P value show up? The negative 7. So we can say negative 7 equals 4P. And the first thing we can do is multiply both sides by. These would cancel, telling me that negative 28P equals, then we would divide both sides by negative 28, which tells me that P is equal to negative 1/28. Now I went on and just plugged the vertex in, or just gave us the vertex, because we plug H and K in. Well, it'd just be negative 1, comma negative 1. Now the focus is, for x equals, is H plus P comma K. So that'd be negative 1 plus negative 1/28, which is negative 1 and 1/28, or negative 29/28 if we wrote it as an improper fraction, comma negative 1. The directrix is going to be x equals, well, we'd have negative 1 minus negative 1/28. Well, the negative and negative would make a positive, which is negative 27/8. And lastly, our axis of symmetry would be y equals negative 1. And that would be it. Any other questions on that there? Because 20 and 22 are going to be the exact same. Homework? You can just put it on my desk. So any questions on 20 or 22? Or 23? 24 through 27. 24 through 27. Well, what's the main goal? We find the equation, yes? To find the equation, I need what? H, K, and? So I still need the same 3. Well, they gave us the vertex, yes? So H is equal to K is equal to, and P is equal to? Well, we don't quite know, but I do know that the focus is going to be K plus P, because it's the one that changed. Now, because it is the one that changed, we also know that our equation is y equals 1 over 4p, parentheses, x minus h squared plus k, because that's going to be our equation, yes? Well, so we're saying that k plus p is equal to, now we know that k is -9. Now to get p by itself, we would add 9 to both sides, telling me that p is equal to, so since it's -6.5, when we add 9 to it, we should get 2.5. So the value of p is 2.5. So in p's pot, we can plug in 2.5, plug in 7 for h, and -9 for k. Well, is 4 times 2.5 going to give me a whole number? Well, yes. And 4 times 2.5 is 10. Now we'd have x minus 7 squared inside, and then minus 9. And that's it. Because again, on these here, just kind of like with the last ones, once we find h, k, and p, we plug in respectively, where it's supposed to. Yep. Because if we're wanting the equation, we plug h, k, and p into the equation. If we're wanting the vertex, directrix, axis of symmetry, or the focus, we plug h, k, and p into those spots. And that's it. Question on this here. Questions on 25. Question on 26. Okay. Well, the vertex is h and k. Now, since we do have y equals for the directrix, we know that this is k minus p because it is y equals. Well, the directrix for y equals is k minus p. Now, it's already told us that h is -6, k is 6. So all we need to do is find the value of p. K is 6, so 6 minus p is, we can subtract 6 from both sides, which tells us negative p equals -2, or p is equal to +2. So y equals 1 over 4 times p. Well, p is 2, parentheses, x minus what? -6, or x plus 6 squared plus 6. And again, when plugging those in, be careful that you're plugging in correctly for h and k. 1 over 4 times 2 would be 1/8 times x plus 6 squared plus 6. And that's it. Questions on this here? Are we good with these here? Yes. So 28.7 would be similar to what we just did. Again, it's just finding h, k, and p. Now these last types, I'll look at one of each because I think we have time. In this one here, find the equation, or find the quadratic equation, or find the equation from the given information. Well, we're given the vertex and a point. So we're using y equals a times x minus h squared plus k. Well, the values of h and k are 2 and 4. We got that straight from the vertex. But we still are missing what? The value of a. And that's where we use the point, because we're plugging the point in for x and y. Because what it's saying is that 6 is equal to a parentheses 0 minus 2 squared plus 4. Or really, when we plug 0 in for x, the value of y should be 6. Well, 0 minus 2 squared, 0 minus 2 is negative 2. And negative 2 squared would give me positive 4. Now what would we do next? Subtract 4 from both sides, which would tell me that 4a equals 2. Divide both sides by 4. Tell me a is equal to 1/2. Let's see here. Plug a back in to the original equation before we plugged in the point, and we have our answer. Question on this here. Okay. Let's look at the last one. This one here is our x-intercept form. Well, since they gave us the intercepts, we do have the p and q value. Since p is negative 14, well, the negative and negative would give us plus 14. Since q is positive, it would just be x minus 2. We could have written this, the first one, as x minus negative 14, but the negative and negative would still give us a positive. Now at this point here, we can plug the point negative 72 equals a parentheses negative 10 plus 14 times negative 10 minus 2 in to find the value of a. Well, this here would be negative 10 plus 14 is 4. Negative 10 minus 2 would be negative 12. Negative 12 times 4 would be negative 48a. And last but not least here, we would divide both sides by negative 48. Telling me a is equal to, well, it'd be positive. It's not going to divide evenly, but it would simplify. You want to plug in 78 divided by, or 72 divided by 48. See what you get. 1 point something? 1.625. So the final equation is y equals 1.625 parentheses x plus 14 times x minus 2. And that's it. Because once we plug the intercepts in for this one here, we find the value of a and plug it back in. And that's it. Yes. No.